Good evening, everyone. I am Dr. I. Veeranjaneyulu, coordinator of the Aditya Learning Academy, and it is my pleasure to welcome you all to the online certification course on Digital Hardware Engineering with FPGA. This event is organized by ALA in association with the Department of ECE, Aditya University, Surampalam. Let me start by giving you a quick introduction to our university. Aditya University is a premier institution committed to excellence in education, research, and innovation. Located in Andhra Pradesh, India, the university offers a diverse range of UG, PG, and doctoral programs across various disciplines, including engineering, management, sciences, medicine, and humanities. With a strong emphasis on academic rigor and industry oriented learning, Aditya University collaborates with top global institutions to provide international exposure to students through study abroad programs, research partnerships, and faculty exchange initiatives. The university also fosters entrepreneurship and innovation, equipping students with the skills needed for the evolving global job market. Aditya University is home to state of the art infrastructure, cutting edge laboratories, and vibrant campus life that nurtures intellectual and personal growth. The institution is decided to shaping future leaders by providing a holistic education that integrates theoretical knowledge with practical experience. Now I would like to introduce our Aditya Learning Academy. As a center for teaching and learning at Aditya University, ALA is dedicated to advancing education through specialized certification courses. So far, we have successfully completed 3 online certification courses and 2 online lecture series. First one is Mission Learning and Gen AI. It was conducted from August 5th to 16th, 2024. The second one is Data Visualization with Power BI and Tableau, conducted from September 23rd October to 4th October 2024. The third course is Certification course on AI tools, conducted from December 23rd to 28th in 2024. In addition, ALA has also conducted 2 online lecture series. The first one is Emerging Trends of Research in Electrical Engineering. It held from November 6th to 16th, 2024. The second course is Research Scope in Emerging Areas of Civil Engineering. It held from 21st January 2025 to 31st January 2025. All of these programs received a great participation, and it is clear that there is a strong interest in learning these valuable skills. Today, we are starting another exciting program focused on digital hardware engineering with FPGA. A total of 240 participants have registered for this program, and which will run for the next 6 days. During this time, you will have the opportunity to engage with expert resource person to explore topics such as introduction to FPGA and digital design, FPGA architecture and design flow, introduction to Verilog and digital design basics, combination logic design in Verilog, sequential logic and finite state machines, test benches and simulation in Verilog. This program is designed to help you understand these areas better and gain skills to advance your professional and personal growth. Today's resource person is Dr. Muhammad Taj. Dr. Taj is a distinguished academician and administrator currently serving as the coordinator of international relations and assistant professor in Department of ECE at Aditya University. With a strong commitment to global academic collaboration, he plays a key role in fostering partnerships with prestigious institutions worldwide. Dr. Taj expertise in nanotechnology, he actively engages in research, mentoring, and academic initiatives aimed at enhancing the quality of higher education. His vision is to create a dynamic learning environment that bridges the gap between academia and global industry standards. So finally, I would like to invite today's distinguished resource person, Dr. Muhammad Taj. Thank you all, and I wish you a productive and great learning experience. Thank you all.
A very good evening to one and all present over here. So myself, Dr. Mohammed Taj. So currently I'm serving as a assistant professor. So already introduced by Dr. Viranjali sir. So thank you for that. So before starting this course, I would like to convey my heartful thanks to all the participants who are registered for this course. So maybe this course may give very good knowledge regarding in VLSI in that FPGA. So we know that coming days we have the very good opportunities in VLSI. So in that way, so we have been started some courses. So in that way, we have been started the course in the FPGA that is related to VLSI. So now we will discuss about the main objective of our course. So later we will go further as per the schedule. So our course is the digital hardware engineering with FPGA. So we know that currently FPGA having a very good programming IC. So whatever kind of electronic gadgets we want, so directly we can able to take FPGA and we can able to dump the program in that. So with that we can able to make any kind of the device. So with FPGA we have many applications like communication domain, electronic and industrial domain. We have the many applications with FPGA. So how we can able to work with FPGA, then how we can able to dump the program and which kind of the things we have to be follow. So this course will be give brief idea about that. So coming to the today's content, so today we are going to be discussing about introduction to FPGA and digital design. So in that we are going to discussing about overview of FPGA technology and its applications. And before that, how FPGA came into the picture. So these all things today we are going to be discussing, and basics of digital logic design and FPGA development workflow, and finally which kind of setups we required. So to make efficient FPGAs, that we will learn with in this lecture. So coming to the historical introduction, so we know that our electronics is started with vacuum tubes. After that it came with the BJT. So whenever BJT came, so total we know that our electronic generation is going to be changes into very bigger size to the smaller one. So with that whenever after transistors we are getting lot of change in our electronic gadgets. So we can able to say this is one kind of the new generation for the electronics. After that, when we invented the ICs, so again one more new generation came in the electronics. With that, so all devices, all electronic gadgets are optimized very less size. So like that, before we know that the first generation computer is theater size, after that tabletop. Nowadays we can able to utilize all computer applications with our mobile itself. So that will happen with only IC technology only. Whenever IC technology we got, so we got one new generation of the electronic gadgets. So here we will start with the thing. So generally IC started with the 74 series, that we all know that in digital we are making different types of the experimentation with the help of ICs. In that we have the OR gate 7432 and AND gate 7408, like that we have the many gates. So with that our IC generation is going to be started. And coming to the ICs, so previously ICs we can able to make with, we are drawing the all whole circuit on the cardboard. After that, so that IC we are converting into the layout diagram. So that layout diagram we are processing for the fabrication. So it will be take very lengthy time. So for that purpose, we got the one new era like that PLDs. So coming to the PLDs, we can able to call it as the programmable logic devices. So coming to the programming logic device, so these are the, we have many type of the programmable logic devices. So whatever content we want, means whatever type of applications we want, so that application we can able to dump into that PLD, then we can able to make whatever application we want. For example, if I want full adder, that code I will write and I will dump into the PLDs, then obviously that PLD will work as a FPGA, so work as a full adder. So like that, whatever program we are dumping into the PLDs, correspondingly, so that application will run. So that is the one of the advantage of this programmable logic devices, that thing we are going to be discussing today. So coming to the basic introduction about the PLD. So before going to the FPGA, so FPGA also one type of the PLD, advanced PLD only. So before that, we need to know some kind of the basics. So where programming is started. So why programming is started in the electronics. So whenever we are going for the IC fabrication, so initially we are starting with 10 number of transistors. After that, we went for the 100 number of transistors. That 100 is went for the 1000, 10,000 like that. So till 100 transistors, maybe it complex, but we can able to draw on the cardboard. Correspondingly, we can able to make the layout for that, and we can able to send that for the fabrication. But whenever transistor count is increases, so like the 10,000 and 1 lakh, nowadays millions of transistors we are fabricating in the IC. For that purpose, so man-made things are not possible. For that, we need some kind of the automation. So these automation came like that. We are getting the two types of the things. One thing is directly we can able to draw the circuit with the help of some kind of the EDA tools, and that EDA with that EDA tools we can able to convert as the layout, and we can able to send for the fabrication. So it will this process, it will be take somewhat time taken, because whatever customized application we want, we have to design, we need to convert as a layout that we can able to send for the fabrication. So it will be take very long time. So we have the another era like that, that is FPGAs or program PLDs. So here whatever application we want, means whatever circuit, digital or analog circuit, whatever circuit we want, that circuit we are dumping into the existing FPGA, and instantly we can able to get the application. With that, we can able to make many application instantly by going in the conventional way. So this is the main advantage of the PLDs while comparing in the formal fabrication process. So in that purpose, today we are going to be discussing about the PLDs. Generally, if we are discussing about the PLDs, generally PLDs is consisting of the group of gates like that, AND arrays, OR arrays like that it will be have. So before that, we are using the NAND gates to make any kind of the circuit. So we know that NAND is a universal gate. With the help of that, we can able to make any kind of the digital circuit. But whenever we are getting these PLDs, that PLDs are consisting with the AND arrays and OR arrays. So with that, we can able to make any kind of the circuit, whatever customer and whatever application we want, we can able to make that kind of the circuit. And coming to the general structure of the PLD, so now only we discuss. So one or both of the gate arrays are programmable. So generally here we have the PLDs. So we have the input side and output side. So input is number of inputs will come. So output side number of outputs will come. So in between, so how many arrays of AND gates and how many OR gates we have used. So that will be come into the picture. And coming to the programming, so programming is one of the very sensitive way. So how we can able to program means burning of the fuses is one of the technology is initiated in initially. Now we went for the FPGA, and here we are not burning the fuses. That technology we will discuss in the next classes itself. So while we are discussing about the PLDs, generally the PLDs are mainly classified into three types. In that, the first one is the PROM, programmable read only memory, and second one is the PLA, programmable logic array, and third one is the PAL, programmable array logic. So for these all three type of devices, they have the input, and they have the input, and they have the output. So input side, we can able to say here we are programming or not. Here output side we are programming or not. So along with this classification, so these devices are classified into three types mainly. In that, if we are we can able to say that input side generally we are using the AND arrays that we are describing over here. If we are discussing about the output side, so output is having the OR array. So input, whatever number of inputs we are interconnected, that place we are using the AND arrays. So wherever we are taking the output, so the product of sum of products, but wherever we are taking that product term, so that we can able to take with the help of OR array. So along with that, we have the mainly PLDs are classified into three types. In that, the first one is the programmable read only memory. In that, input programming is fixed. So here we can't able to make change in the input side, means AND arrays are the fixed, so we can't able to change any thing at the input side, and OR array is the programmable. So output, whatever functionality we want, that functionality we can able to make program. So how we can able to do program means that we can able to do the with the help of burning of the fuse. Here I will tell the what is the meaning of burning of fuse means. So generally if we are taking about one fuse, so this is the generally fuse structure. So for example, if I am telling, so whenever if I burn this fuse, it will be coming as a open circuit. For example, if I applied 1, so 1 or 0, we can't able to get anything at the output side. If I hadn't burned this fuse, whatever output we want, input we are giving, that output I can able to take at the output side. So this concept we can able to call as the programming. So that programming is happening with the burning of the fuses in PROM, PLA and PAL, and FPGA is another part, so that we will discuss in later. So coming to the second type, so that is the PLA. So PLA, if we are discussing about input side, that is the AND array side. So AND array is the programmable, and if we are discussing about the OR array, so OR array also program. So here input we can able to program, and output also we can able to program. So this is the flexibility we have, that so easily we can able to make whatever combinational circuit we want, we can able to make easily with the help of this PLA. And coming to the third type, so third is the PAL. So that is AND array is the programmable, output is fixed. So whatever OR arrays are there, OR arrays are fixed terms we have. So whatever programming we want, that we can able to do with the help of inputs only, with that is for the AND array. So this is the basic types of the PLDs while we introduce in the initial stage. So these PLDs are three types. After this PLDs we got the CPLD, and after that we got the FPGA. So that FPGA only we are going to be discussing in coming sessions. And we will discuss this everything in detail, because we need to know how we can able to make different kind of the circuit. So why I have chosen I am telling these basics means many people they are with the second year and third year range BTech. So for that purpose, if we started this programming means they can able to understand very detailedly about this FPGAs. So coming to the first PLD, so first PLD we are starting with the PROM, that we can able to call as the programmable read only memory. So coming to this programmable read only memory, so here already now we discussed about the AND array with buffer inverters are available, and if we are discussing about the PROM, so PROMs are having the n to 2 power n line decoder. So decoder we know that, so decoder coming to the expression n into 2 power n. For example, my the number of inputs are 3, so that is the n value is the 3, then I can able to make change like that. So my decoder size is the 3 into 8 decoder. So here for inputs I can able to take the 3, and output functionalities I can able to make 8 functionalities. So likewise we can able to make the PROM. So in PROM the basic heart of that PROM is the decoder only. Depends upon decoder size we can able to make the which kind of the functionality we can able to do it. Then coming to the OR array, so OR array is a collection of programmable gates. So whatever output we want, we can able to take that output with the help of OR gates. So that we will discuss in examples in next. So coming to the decoder, so decoder is a mean term generator. So whatever mean terms are there, that will be generated by the decoder. So whatever output product we want, so that it can able to generate with the help of OR gates. And if we are discussing about the variables, so decoder plays a major role for the PROM. So n is number of inputs and 2 power n is the number of outputs. If our inputs is 2 or 3 or 4, so likewise we can able to make the size of the PROM. And here n is the number of inputs. This is the general size of the PROM. So 2 power n into m. So 2 power n is decoder output and m is the output terms from the OR gate. And we can able to realize many Boolean expressions with the help of this PROM. So we can able to make any kind of the combinational circuit with the help of PROM, that we will see in the next slides. And coming to the PROM structure, so already we discussed about that. So input we have the input buffer and inverter. So buffer it will store the temporary data and it will be give the logic restoration. So here we have the fixed AND arrays, and here we have the programmable OR arrays. So whatever input we have for the PROM, so here here we can able to say that. So here we have the 3 inputs. So 3 inputs here we have. So here we have the AND gate. So here we have the OR gate. So whatever output we want, we can able to take from the OR gate. So whatever inputs we have, that we can able to give from the AND gate. So these things we will discuss with one of the example. So now this complete structure we can able to see over here. So while discussing about the PROM, so this PROM having the 3 to 8 line decoder. So this 3 to 8 line decoder having the 3 inputs that named as a B0, B1 and B2, and one enable input is provided. So this is 3 by 8 means 3 inputs are there, 8 outputs are we provided, and here we are keeping the OR gates to take the output. So here we have the S0 to S1, S2, like that we are keeping many outputs. So S2, S0, S1, S2, S3, S4, S5, like that we have the many outputs over here. With that we can able to take that thing. So already previously we discussed that here. So PROM AND is fixed, OR is programmable. Now here whatever AND is there, that is the fixed. So whatever OR is there, that we can able to program. So this cross mark showing as a programming. Then how that cross mark will come means already we know that if we have 3 inputs like that, if we are discussing about the B0, B1 and B2, so if we have 3 inputs, then possible input cases we can able to apply as a 8. So 0 0 0 0 0 1 0 1 0 0 1 1 up to 1 1 1 we can able to apply that. So how we can able to realize the output means this we can able to write as a B0, B1, B2. So here this is the B2 bar, this is the B1 bar, and this is the B0 bar. So likewise we can able to get the all expressions. So whatever expression we want, that we can able to program. For example, my first S0 is consisting as a expression like B0, B1 bar, B2 bar plus. So here this is first one, and this is second one, B0, B1, B2 bar. So that is a B0, B1, B2 bar plus, like that wherever we are getting program, these all outputs we are getting with the OR functionality. So the we can able to get the output, whatever required output we want, we can able to make like that. So this is the basic working of the PROM structure. Now we will go for one example. So after that we will do one general example also. So they given one realization with three inputs. So here three inputs are the x0, x1 and x2. So here they given like the two functions, that is f1 is the first output and f2 is the second output. So here f1 are three inputs, f2 also three inputs. These are the terms we want. So here first one we have the 0, 1, 2, 5, 7 and second term we have the 1, 2, 4, 6. Then how we can able to make these things? Now already we discussed that PROM having the fixed and programming and output side OR gates we can able to program with ourself itself. So that we will discuss over here. So here we are taking the three inputs x0, x1, x2. So this is x0, x1, x2. So these are the inverter buffer. So here output I can able to get x0 bar. Here I can able to get x0 directly. So similarly here I can able to get x1 bar, here x1. So likewise here x2 bar, here we can able to get x2. So like that we can able to get all 8 functionality, like that 3 zeros to 3 ones. Means it will be starts from the x0 bar, x1 bar, x2 bar till it will be come as a x0, x1, x2. Likewise we can able to get 8 possible condition over here. And coming to the these all 8 possible conditions we given as a fixed manner. How we are giving fixed manner means first we are connecting as x0 bar, x1 bar, x2 bar, so that we can able to call it as a 0, 0. So 0, and next we are connecting as a 0, 0, 1. So now we can able to call it as the x0, x1 x0 and x1 bar and like x1 bar and x2 bar, like that we can able to connect. So till my final output I can able to get as a x0, x1 and x2, that we already explained here. So 3 zeros to 3 ones we have the fixed connection over that. So this fixed connection we can't able to do the change. So these all connections they came like a fixed connection. So where we can able to make the change means here output we can able to do the change. Here we have the two R functionalities, that is F1 and F2. That F1 we have the 0, 1, 2, 5, 7. Here only here I will give one small very small thing how we can able to program. Means this I will call as a 0, 1, 2, 3, 4, 5, 6, 7. So whatever mean terms they given, so that is they given 0, 1, 2, 5, 7. So here I will connect that only. So 0 I had programmed and 1 I had programmed, 2 I had programmed and 5, 7. So this 5 I had programmed and this I had programmed. So like that whatever number they given in our K-map, so that directly we can able to program. So even we no need to draw this table itself. So directly whatever mean term number they given correspondingly we can able to program here. Now we will see second functionality. For second functionality what they given, so they given like that 1, 2, 4, 6. So we are going to programming same thing. So this 1 we programmed and 2 we programmed and 4 we have been programmed and 6 we have been programmed, like that. So whatever programming term we want, we can able to do that program at the outside output side only. So this whatever input we have, that all inputs are in fixed manner itself. So this is the basic structure and how we are taking example with example how we can able to make the structure, that all we can able to do with the help of PROM. And here we will go with one example like that. So we will design, we will implement one full ladder with the help of PROM. So now I will make that. So PROM having PROM we have to be consist, so that PROM having the full ladder. Generally we know that if we are discussing about the full ladder, so full ladder having the 3 inputs that we can able to call as the A, B and C. So this full ladder we having the 2 outputs, that is one is the sum and second one is the carry. So here we can able to write the expression itself, that we know that sum is equal to A XOR B XOR C, and we have the carry. So carry we know that AB plus BC plus AC. So along with that we directly we can able to give the number, so that sum we can able to write that terms as a K map 1 2 4 7, and carry we can able to give as a 3 5 6 7. Then how we can able to design this PROM with the help of this? Now we will go with that. So three inputs means we have to take three inputs, like uh, three inputs we need to be take it. So here we will take one buffer. So here I will take, this is my A, and here I will take one more input, this I will call as the B. Here I will take one more input, that I will take as the C. So here we need to go with the inverted out things also. So here A bar, here we will get A, here we will get A bar. So here B we have, and here I will draw the B bar. So here we have C, here I can able to draw the C bar. So here how many AND gates means that already we know. Na? So if we have three inputs means we can able to use the 3 to 8 decoder. So this 3 to 8 decoder having the 8 AND gates. So 1, 2, 3, 4, 5, 6, 7, 8. So whatever inputs are there, so these all inputs we are saying that this is the fixed programming, we can't able to change that program. Then how that fixed programming is there means, fixed programming we are representing with the dot. If we are programming that, we are representing with the cross. So here fixed programming with the 0 0 0 and 0 0 1 0 1 0 1 0 1, like that. The finally we will get 1 1 1 is our programming, like that. Here we can able to get the all functionalities. And here output, how many terms output functionalities they given. So here they given, one is the sum and one is the carry. So here we require the two OR gate. So this is one OR gate, this is two OR gate. First OR gate for the sum and second OR gate for the carry. So these term we can able to program. So how we can able to program this term? Here only we are discussing that. So this is 0 1 2 3 4 5 6 7. Now 0 1 2 3 up to 7 we given. So whatever term they given, that we can able to program. So what term they given? So 1. So directly I will go to program 1, and here 2, here 4, and here 7. So my sum is completed. Then easily we can able to make this full adder. Now here we need to be programmed with so 3 5 6 7, like that. So whatever function number they given, directly we can able to program that, and directly we can able to do the whatever functionality we required, we can able to do that kind of the functionality. For example, only here I had given that. So whatever functionality we want, we can able to do that kind of the functionality with the help of this PROM. So PROM is a one kind of the programmable device. So whatever digital functionality we want, that we can able to make with this. So this is the one of the first PLD. With this PLD we can able to make any kind of the combinational circuit, but here we have small limitation, that so that limitation is number of inputs. So if number of inputs are increases, so we need to be use decoder size is very higher size. So that is one kind of the complexity we can able to observe with the help of this PROM. So this is the first type of the programmable logic device. And the second type of the programmable logic device is the programmable logic array. So that we can able to call as the PLA. So first we have completed సరే ఏమైంది చెప్పారా వాళ్ళకి? పర్లేదు, మీరు కంటిన్యూ చేసేద్దాం, వాళ్ళు చూసుకుంటారు. పర్లేదు, నో ప్రాబ్లం. మళ్ళీ వాళ్ళకి డిస్టర్బ్ అవుతారు. సో now coming to the second thing. So second is the programmable logic array, that we can able to call as the PLA. So here the advantage of PLA is, so both side are the programmable. In PROM already we seen that. So input is fixed, we can't able to program that. So output is not able to output we can able to program. So coming to for PLA, so PLA input side also we can able to program, output side also we can able to program. Means input functionality we have the controlling, output also we can able to do the controlling. And I will tell you one example for that. In PROM we have the 3/8 decoder. So 3 inputs are fixed. If I want to make any 2 input gates, there's some kind of difficulties we can able to face with that. And if I want to to do with this thing. So how many inputs I can able to program, that only I can able to program, means whatever input terms we have, we can able to do easily with that thing. So that is the one advantage over we can able to see in the programmable logic array. Now we will discuss the number of inputs and outputs for this. So coming to the PLAs, now only we discuss that PLA is a programmable logic arrays. So here we have the number of inputs that we can able to representing with the n. So if we have n input, so we have the product term, so that we are, for product terms we are using the AND gate. So we have the, we are saying that we have the product time, so that we are calling as a P, we denoting with the P. So the number of AND gates, that P represent as a number of AND gates, and number of outputs representing with the M. So the size we can able to representing with N is the number of input, and P is the number of AND gates, and M is number of outputs. So this is general way how we can able to define the size of the PLA. So coming to the PLA, the typical PLA size, so we have many PLAs. The typical size of the PLA is 16 inputs, 48 AND gates, and 8 outputs PLAs we can able to see over there. So coming to the PLA structure, so here this is the n is number of inputs. So here also inputs, they have the inverted buffer. So one input directly we can able to take, one input inverted output we can able to take it. So likewise n number of inputs, each input they having the inverted buffer, and these are the number of product term that we are representing with the P, and the output we can able to take that we are representing with the M. That output similarly we are taking with the R only. The meaning PROM, PLA, PAL. So PAL is going to be, so these all having the input are the AND arrays, output are the OR arrays, but the term is changing like that. So whatever we are programming, so input we are programming or output we are programming, or both we are programming, accordingly which type of PLD we can able to use, that we can able to choose it. So coming to the PLA, so here also we can able to program, here also we can able to program. So how we can able to program? So this burning of the fuses we can able to make this change. So likewise we can able to program the whatever functionality we want, we can able to do that with the help of this PLAs. Now we will go with one small example with that. So here we have the 3 inputs that we are named as ABC. So that ABC having the each input they having the inverted buffer, and here we have the four product terms, that is the 4 AND gates we are taking. Then output, so here outputs we have 2 outputs, the 2 outputs we are taking with the R. So by seeing this diagram we can able to observe that, so input side we have the cross mark, output side also we have the cross mark. So that cross mark is represent as we are programming. So so in PLA, so nothing is fixed. So whatever programmable thing we want, we can able to do that. So here they programming like that. So here A, B they program. So here we can able to get the A, B. So C not programmed means, so C own we can't able to consider that C. And here A is there, and C bar is connected, that we are representing with AC bar. And here they programming A and B bar, so that we representing as a B bar. And here we are programming with B and C bar, that we are doing like that. So likewise we can able to make any kind of the programming with the help of this PLA. So compared to the PROM, we said na, in PROM these all are the fixed. So means fixed number of input we have to be considered. So if our combination circuit having fixed number of input, then only we can able to go with PROM. But our combination circuit we can able to choose with number of inputs, like 2 inputs, 3 inputs, 4 inputs, like that. If we want to choose that thing, so that we can able to go with this kind of PLAs, because here input also we can able to program, output also we can able to program. For example, here we have the ABC. So I want to my combination circuit having only 2 input, that are the A and B. Then I won't program this directly, I will program these 2 things only. And in future I want to change that, means my functionality having three inputs means that we can able to make like three things. So likewise we can able to do the programs with the help of this kind of the structure. So this is another type of the PLD. There we can able to make the programming in input side and output side also. And here we will go with one example with that. So here we have the three inputs. So now we will design one PLA with the help of this example. So here we have three input, means we will take three inverted buffers. So this is one, that I will name as A, and here I will take one more thing. So one more inverted buffer, we will name this as a B. So here we will take one more inverted buffer, that we will name as the C. So here how many output functionalities are required? So generally that is depends upon things. So here I will take 1, 2, 3, 4, 5, 6, 7 and 8. So depends upon requirement, maximum we can able to take 8 product functionalities and get. So this 8 I have been drawn over here. And the first in this is input side. So we have discussed over here. Here input is not fixed, we can able to program this input also. And here output is also programmable. Here 2, 3 output functionalities are there. Here I will make 3 OR gates. So these 3 OR gates we will program here. Means here input side we can able to program, and obviously output side also we can able to make the program. And here how we can able to program means we will go with first functionality. What is my first functionality? A into B into C. So A into B into C means here I will program A, here I will program B, here I will program C. So now the functionality I will get as A into B into C. Now here I want the first functionality F1. So F1 means where I can able to program. So directly I will program over here. So likewise whatever input side we have the flexibility, and output side also we have the flexibility to do the programming. And coming to the A plus B plus C. So if we are discussing about the A plus B plus C, and we have to go with the product terms only. So we want A plus B plus C. So separately we will discuss that. Here I will do the program with A, and we have the B. So here I will do the program with B. So here I will do the program for the C. And here I will get only A. Here I will get only B. Here I will get only C. So these I will connect for the here, here, here. Now my output is A plus B plus C. So likewise input flexibility here we have. So likewise A bar B bar C means that I will do program with the help of A bar and B bar and C bar. That programming I will make over here, and I will get the third function. So this is very convenient way so to do the program with the help of PLA. Means whatever logic function we have, that logic function have the number of, so they having any number of inputs. So that it depends upon the number of input, that functionality we can able to change that. So I will tell you one example. So you want to do the 2 input programming. So any combinational circuit you want to do with 2 input programming. But you went for the you went to the market, so you purchased one PLA. That PLA they having the 4 input PLA. So we can able to program here. Yes. So here I can able to utilize only 2 inputs, and remaining I will skip that thing. So likewise that much flexibility we have for the PLA. So that is the one of the advantage of PLA. There easily we can able to make any kind of the program. And coming to the last PLD that we can able to call as the programmable array logic. So coming the programmable array logic, here the structure we can able to see. So this is also similar like theory, whatever we discussed previously, same kind of inputs and outputs we can able to make over here. So here we have the 4 inputs. So here we have the n number of the AND gates. So depends upon that we can able to make that. So here we have the OR functionalities. So if we are seeing the here outputs, so outputs are fixedly they have been connected, but input we can able to program. So see, input we can able to program, output or we have the fixed parts. Means so whatever functionality we want we can able to do at the input level only. These we can't able to make at the output, because output we have every places fixed programming. So here we can't able to change that thing. So whatever input is there, that input I can able to make change easily with the help of this PAL. So the difference between these three PLDs are one PLA is both side programmable, very flexible. PROM is the so output is programmable, input is fixed. So this is vice versa, it will be happen. So accordingly we can able to make different examples with this. So this is about the basic PLD history initially we are using. So when we have the simple combinational circuits like adders, subtractors, like that, we have very less number of input combinations, we can able to use this kind of the PLDs. But here we have one disadvantage like that. So in all three types of these PLDs, we have the disadvantage like that, the limitation of the inputs. So with that we can't able to make the IC, that IC having the many inputs. For example, my IC having the more than 100 inputs, that I can't able to make this with the help of PLA or PAL and PLD, because the structure is complex. Because input side we have the n because we have the n arrays, output side we have the OR arrays. If we are increasing the inputs, this array size is going to be increases. Whenever this array size is going to be increases, lot of complexity we can able to get. So again size is going to be increases. So for that purpose, one again new kind of the PLD we got, so that we can able to called as the complex programmable logic device, that we can able to call as the CPLD. So coming to the CPLD, so CPLD is not a bigger kind of the construction. So here till now we discussed three types of PLDs, right? So in that first one is the PLA, PAL and PROM. So like that we discussed the three programmable devices. With that programmable devices we can able to make any kind of the combinational circuit. And now coming to the CPLD. So CPLD is not a bigger thing. So with CPLD we can able to increase the number of input size. So our IC we having the more than 100 inputs, like that if we have that I can able to make with the help of CPLD itself. But CPLD is here we can able to see the construction of the CPLD. This CPLD having the group of logic blocks they connected, interconnected, like that. For example, if I am taking PLA, group of PLAs we interconnected, and how many PLAs we want we can able to interconnect each other, and we can able to get the very big size of the IC. So likewise we can able to make the CPLD. So CPLD programming not have any kind of the enhancement. In CPLD just we can able to do the program like whatever now we discuss PLA, same kind of the programming we can able to do with the help of this. But the difference in PLD is, so group of PLAs we are interconnecting. So here we have the IO blocks, so that we can able to work for the inputs and outputs, and we have the interconnection switch matrix that it can able to interrelate that all PLAs are PLD devices, and these each logic block having their own input and output block, that each block they having the AND arrays and OR arrays. So likewise we have the construction of the CPLD. So with CPLD we can able to make some kind of the more complex combinational circuits. So now we discuss about the PLDs. Now with all three PLDs, with that we have the some kind of the limitation. So that logic very less kind of the logics we can able to perform with the help of these previous three type of PLDs. But if we have some kind of complex functionalities that we can able to do with the help of CPLDs. This is the advantage of the CPLD. Now these are the basic things till now we discussed. Now we came to our picture, that is the FPGA. So before FPGA we have these type of the programmable devices, that is a PROM, PLA and PAL. After that we have the CPLD also. Now coming to the our picture, so that is the FPGA that we can able to call as the field programmable gate array. So here programming is somewhat different, like that. Till now programming means we discussed about the input, we have the group of AND arrays, output we have the group of OR arrays, like that we have that thing. But so coming to the FPGA, so no array kind of things it will be there. So very simply we can able to make the program with the help of simple logic functionality that we will discuss in the further classes. And we will discuss about the FPGA now. So whenever FPGA came, we got lot of changes in our electronic gadgets. Likewise, so whatever setup box we are seeing in our home, so that will make with the FPGAs only. So whatever mobile phones we have inside, that complete processor is the FPGAs only. And FPGAs we can able to give the very good. So previously we can able to see the change in processor. So initially we know that so 4004 processor we have. After that we got 8085, 8086, 80286, 386, 486. After that Pentium process, P1, P2, like that. After that dual core, quad core, and like that. Now we are with I generation process. So now we have with the I11 process, like that. So previously one processor to another processor changes, we have the long gap. Now processor to process we don't have any long gap. So why? Because previously if we are making that kind of the fabrication, means that is taking long time. Now simply we will take the FPGA. So whatever processor programming we want, that we can able to do in that FPGA, easily we can able to get the processor. So that is the one of the good advantages we have whenever we got the FPGA. So now we will discuss where we can able to use this FPGAs. So FPGAs having many application like artificial intelligence, robotics, and FPGA. Nowadays we can able to say that AI is one of the hottest thing. So for electronics also we need the AI. So to do that all kind of the programming, FPGAs also plays a major role. Why? Because you can able to see that AI is a programming only now. So okay, AI is a programming only, where you were incorporate that program. For to incorporate that program we need the hardware. Na? So that hardware is nothing but a FPGA, we can able to see that. And point by point we will see how it will be work. So coming to the FPGA, so FPGA having mainly 3 blocks only. In that the first block is a programmable interconnect. So whatever outside boxes we have, so these all outside boxes we can able to call as the programmable whatever so whatever outside boxes are there, that all boxes we can able to say that IO pads. IO pad means so this outside all pins, they can able to work like input or output, that is our flexibly we can able to change that. And here these all outside blocks we can able to utilize for either input or output. And coming to the middle block, so these all are the programmable logic blocks. So whatever logic functionality required, for example full adder, half adder, multiplexer, or some kind of functionality like a flip-flop or any counter, if we want that we can able to program. So where we can able to do that program means that we can able to do program in programmable logic block only. But in here programming not with burning of the fuses, here we are doing program separately, that we will see in next. And so for this input and outputs we need the interconnection paths. That interconnection paths we can able to say that programmable interconnection block, that will give the path from the inputs to the logic programmable logic blocks. So that is a one part they will create that. So that only we are discussing. FPGAs are made up configurable logic block. So what is meaning of CLBs means so CLBs are one part in this programmable logic block. In programmable logic block, so CLBs plays a major role. So with that only we can able to make any kind of the logic functionality that we will see in next. And so programmable interconnection, it will be plays a major role. It will be give path, so give connection between IOs and logic blocks, and internally we have many logic blocks, right? So logic block to logic block we need the interconnection, that all interconnection we can able to make with the help of this interconnection block. And coming to the CLBs are contains a group of logic gates and flip-flops and other elements. So these are the things. So here we are not discussing about the arrays and arrays or arrays, we are not discussing. Here this is some kind of the separate structure only. And coming to the interconnection thing, so CLBs to create digital circuits, we can able to use that. And next, FPGAs can be reprogrammable to perform different functions. So for burning of the fuse, once we burn the fuse, we can't able to go for the reprogramming. But FPGAs are not like that. If you want to do program n number of time, you can able to make that. Now I have the one FPGA. Now if you have interest to do AND gate, so you will dump AND program here, that FPGA will work as an AND gate. After some time you can able to erase that AND program and you can able to make the OR program, or after some time you can able to mode XOR. After that some time you can able to do the full ladder. After some time you can go for the half ladder. Likewise, whatever function programming we want, we can able to do in that FPGA in n number of times. That is the one of the good advantage of the FPGA. And coming to the some advantage of FPGA compared to the previous. So first part we can able to see that FPGAs are low costly devices. Now in my mind I have one good new idea. I want to make one new processor. So one creative processor I want to do. So if we want to do creative processor, we have two ways. One way, I will make all circuitry for that. I will convert that as a layout diagram. After that I will convert as a GDS2 file. Then I will give that for the fabrication. It will take lot of years. So but if we are discussing about FPGA, so I will take one FPGA and whatever processor I want, I will do that corresponding HDL, hardware description language code. That code I will dump into that FPGA, then FPGA will work as that whatever processor you want. So that is the one good benefit we have with this FPGA. And coming to the cost, so FPGA are very less cost only and fast. So compared to the other PLDs, FPGAs are very speed and supported by all CAD EDA tools. They all kind of the tools these FPGAs will support, and high density. So with less size we can able to incorporate many kind of the things, and many IOs also. So previously we discussed about the one limitation that PLDs, PAL, PROM, PLA, where they having some limitation of the inputs. So we can able to give these inputs only. After that we have the CPLD, we can able to increase the number of inputs and outputs. But coming to the FPGA, we can able to again increase the much number of inputs and outputs with the help of FPGA. Means here we can able to make many input and out, many kind of complex functionalities we can able to do with the help of this FPGA. These are the high speed, so reprogrammable and versatile devices. Flexibly we can able to program, reusable, large amount of logic gates, registers, RAM and routines resources we have, quick time to market, easily we can able to produce any kind of the logical functionality in time. Why? Because we are not going for the formal fabrication process. So here we are going for the general, if we know code means, then directly we can able to dump and ready to use that IC. And So SRAM FPGAs provide the benefits of custom CMOS also. So these are, we have very good type of the specifications for the FPGA. So that complete FPGA structure and internal block diagram, how we can able to do that program, all we will discuss tomorrow class. Today we have just basic introduction about the FPGA only. But here one more advantage of FPGA. In FPGA we discuss three blocks. First block is a programmable logic block, and second one is the IO block, and third one is the interconnection switch block. So these three blocks are the programmable only. So see how much flexibility we have. Now already we seen in PLA na, input programming, output programming is very much flexibility we have to design any combination circuit. But compared to here, if we are discussing about FPGA, all three blocks are the programmable only. Means we have a lot of flexibility, means we can able to make any kind of the complex digital circuit with the help of this FPGAs. And so this is the coming to the first topic whatever today we are going to be discussed. Now we will move with the second topic, that is the FPGA development flow. So that complete internal structure we will discuss in tomorrow classes, tomorrow lecture. So today again we will go for the workflow, how FPGA will be we can able to produce whatever functionality we want, how we can able to produce, that we will discuss with one flow diagram. And for FPGA, so here the first thing we need to go with the design source file. So what is the meaning of design source file? Now here one more thing we will need to be discussed, that is very important thing, that is a HDL. So HDL stands for the hardware description language. So hardware description, why we are going for the hardware description language? Because if we want to draw any circuit on cardboard or any system, if we want to design circuit with the number of transistors, it is very complex. If 100 transistors we can able to do, and 500 we can able to try, 1000 we can able to try. If that circuit having millions of transistors, how we can able to draw that in one system or one cardboard? Not possible. But for that purpose we have the one more option, that we can able to go with the HDL. So HDL stands for the hardware description language. So when this hardware description language invented, so in 1980s before, so whenever high speed IC generation is started, at that time, so US Department of Defense, so US Department of Defense, they are collaborated with IEEE, and they have started one hardware description language. So why hardware description language? Means whenever we have the hardware description language, that code easily we can able to dump into the PLDs, directly we can able to get it. Means here no need to draw the any kind of the circuit. Whatever functionality we want, that functionality we will write in terms of a software code. That software code automatically it will be convert as a logic circuit in further levels easily. So here we can't able to go that much in detail circuitry thing. So if we writing the code, so that code will give the circuit. So that with that purpose in 1980s, this US Department of Defense and IEEE, they are started the HDL language, and they introduces first HDL language, that is the VHDL, that we can able to call as the very high speed integrated circuits hardware description language. So this is related to other language. So after some years we have the one more HDL language, that we can able to call as the Verilog hardware description language. This Verilog hardware description language is similar to the C language. So in these two ways we can able to do any kind of the program. So means any kind of the logic functionality we can able to make with the help of these two kind of the programs. But as per our content in further we are discussing in detail about Verilog HDL also. Now we understood now what is meaning of HDL. So HDL is one kind of the software code. If we are writing the software code, we will get the circuit. So that is easy now. So every time if we are defining circuit, if we are drawing the circuit, that is some kind of the difficulties we can able to face. But if we are writing the code, if we are getting the circuit, that is one of the easy way. So directly that we can able to dump into the FPGA, that we can able to directly we can able to get whatever device we want, that we easily we can able to get it. So that design source file we are doing over here, so that we can able to do with the help of hardware description language, either VHDL or Verilog, and that we can able to go for the behavioral simulation. So here all code we will check all functionalities are working properly or not, that we can able to call as the simulation. So that we will do after writing that code. So our code is completely correct, means then we are going for the synthesis. So here we are getting the synthesis is one of the new term. Now previously only I said, right? So if we are writing the code, we will get the circuit. So that we will get with the help of this synthesis process only. So synthesis means which converts the source code into the logic circuit. Means here if we are writing the code, now I will write the code in either VHDL or Verilog. Now I will perform the synthesis and output I will get the logic circuitry like that directly. Then that is one advantage. Here we can't able to draw any kind of the thing. So if we are writing the code directly, outputs we will get. So that is the one good advantage over we have with this kind of the platform. So that is we can able to call as the digital synthesis. After complete getting the circuit, we are going for the functional verification. Means every gate is working properly or not, every input we are getting proper timing or not, that all things we are going to be discussing, checking over there. After that we are implementing. So after that we are going for the design implementation. There we can able to check how many number of gates and how many number of blocks we have. Accordingly we need to go with that. And here we are going for the static timing analysis. So static timing analysis means here we will discuss about the some delays are coming or not. So delay means so input versus outputs. If I am giving input means how much time it will be taking for the outputs, and then generally that delays we will calculate with the help of the static timing analysis. And here we will go for the back annotation if required. So any kind of the changes are required in the means whenever engineer required to make some kind of the change, means so that he can able to change, that engineer he can able to change over there, that we can able to do. So if needed, that we can able to do. And finally that we will convert into the bit stream, that is in terms of ones and zeros. That bit stream file directly we are dumping into the FPGA. So then whenever we are dumping into the FPGA, whatever functionality we dump, so that FPGA work like that only. So here finally after dumping that in circuitly, so we are going to be verified. The meaning of that, this is my FPGA, I want one counter, so 4-bit counter I want. Then what I will do, so I will write the program for the 4-bit counter, either VHDL or Verilog, and we will check the simulation, we will check that, and after that in synthesis we will convert that code into the circuit. Here again we will check the every functional, and after that we will go implement that thing. So here implementation means so it will become as a partitions and placing, routing, all terms we will do here, and after that we will check the delay thing, and after that if needed we are going for the back annotation. After that we are generating the bit stream file. So finally our program is going to be uploaded in the FPGA board, and we will get the final FPGA circuit. And after dumping this bit stream 4-bit counter, and this FPGA will work as a 4-bit counter. Means in whatever logic functionality we want, we can able to dump in the FPGA, and correspondingly it will be work like that only. So this is the general development flow of the FPGA. So this we need to know that, so how FPGAs are working. Means in system we are doing the code, so all we are doing in the system. So finally we are connecting FPGA to our system, and we are dumping a bit stream file into the FPGA. Now that FPGA work like that, whatever we are dumping, it will be work like that only. So that is the thing how FPGA is going to be work. Now coming to the next topic, so that is the setting up the FPGA development environment. So if we want to dump any program into the FPGA, what kind of requirements are needed, so that we will discuss over here. And first we will discuss about the selection of an FPGAs. So coming to the FPGA, field programmable gate array. So FPGA is not, we have a lot of classification. So some FPGAs, they will perform some kind of digital functions only. Some FPGAs, they will work with some analog functions only. Some FPGAs, they incorporate with the DSP processor, digital signal processor, and like that many kind of classification we have in FPGAs. We have a lot of classification. So choosing of FPGA is one of the important criteria. Then how we can able to choose that FPGA? So depends upon our application. Our application is only in digital way, so we can able to choose the digital functionality kind of FPGA. Our function, so our application is with analog, so we can able to go with or if our application is mixed, we can able to choose like that. Or if our application with kind of signal processing, like if I want to take inputs signal like that, my voice signal like that, if we want to take, then I can able to go with some DSP, means some kind of DSP algorithms we can able to enhance. So that kind of FPGAs we can able to do. So that only we discuss now. So ADCs, DS, analog to digital converters, digital to analog converters, memory interfaces is all. So depends upon the thing. And one more thing here, we have to choose the number of pins required. So if I'm designing 150 input and output IC, means I can able to choose accordingly 150 pin IO FPGA like that. And coming to the second thing, so generally the popular boards we can able to get with the Xilinx. So that Xilinx, we have the RTX and Zenith, and Intel again we have the Cyclone and Stratstic and Lattice board. So these are the different kind of the FPGAs. Means many platforms are providing the FPGA. So depends upon platform, depends upon requirement, depends upon the application, we can able to choose what type of the FPGA we want. And next one is the install development software. So this is again one of the important. So we are writing the HDL. HDL stands for the hardware description language. So here we have two types of languages. One is the VHDL and second one is the Verilog HDL. So we are writing the code, means we need one platform software. So which software we can able to choose, means for example, all we know that we can able to go with the Xilinx Vivado or Intel Quartus Prime. We can able to take any kind of the software, so to develop our program. So we can able to, so these software like that, so this Xilinx and all these software like that. So here we can able to write the code. After we can able to do the synthesis, then we will get the circuit. After that we can able to go for the simulation, timings analysis we can able to do, and delay calculations, all we can able to do in this platform. Finally we can able to generate the bit file also. With that bit file, we need the one more software to dump that bit file into the FPGA. So that is the thing we need. So means here we require the software tool. So that software tool is supports that our HDL codes. That is the second setup we required. So here I am telling about the how many setups we need to complete our FPGA program. Means if we want to design anything. So if we have these all platforms, so directly we can able to say we are the one kind of the front end engineer. So we can able to do any kind of the code, and we can able to dump it, and we can able to sell into the market like that. And install necessary drivers. So whenever we have the computer, that computer we need to be connect with the FPGA. So to interconnect that, we need to go for some USB-A with the help of JTAG interface, and like that we can able to connect our FPGA with the help of our PCs. So with the help of that JTAG thing, we can able to go with that. And next one is the connect the board to your computer. So finally, if we have a proper connection, that USB or JTAG, and that after that we will do that connection. So in between PC and FPGA, and after that configure the development environment. So here inside we have the one software to configure this FPGA bit stream, and finally design our FPGA circuit, and finally we will design our FPGA circuit. So with that design, after again we will go for the simulation. So after simulation we are going for the synthesis. Synthesis is a way how we are converting the code into the circuit. So after, if we are getting circuit, so that circuit we need to place where we require, and there we can able to interconnect the all kind of the blocks. And this part I will tell you some in detail. So if we are going for the synthesis, so our code, for example here I write it some code, this code will be convert as this like a circuit diagram, like that it will be converted. Now this circuit have many blocks, so this circuit I will draw like a block diagrams. So here we have the many blocks, so these all blocks are interly connected. Then so these blocks I can able to change, so my IC size only this much, so these all blocks I will make change like that, so all I will keep like that. And whenever I going to be interconnected, that path will be changes, so some paths will come longer, some paths will come shorter. If we have a longer paths, again we can able to get the problem of delay, that we can able to go with some kind of the timing analysis. Whenever we completed this all process, we are generating the bit stream. So with that bit stream, so we are dumping into that bit stream into the FPGA. Finally that process we can able to call as the programming of the FPGA, and finally we can able to get the final circuit with that. So likewise we can able to make and we can able to program the any kind of the circuit. So this is the today topic, so whatever we discuss. So one time we will recall all these things what we discussed today. So today we are started with some basic thing, what is meaning of. So first we have to know what is FPGA. So before going for FPGA, we discussed about the PLDs. So PLD stands for the programmable logic gate. So that initially whenever we got the some kind of automation, so there we are started with the IC generation. So we know that 74 series ICs are coming. So at that case we are getting the PLDs. So coming to the PLDs we are classified basic PLDs in three types. In that the first one is the PROM, and second one is the PLA, and third one is the PAL. Then how we classified these two means these all three devices, they are consisting with input and arrays, and output are the R arrays. So the programming concept will come. So which we are, so AND arrays we are programming, or R arrays we are programming. Accordingly we are discussing that. So if we are discussing PLA, so input side we can able to program, means AND array we can able to program, our output side R array also we can able to program, that flexibility we have. But PROM and PLA only one side we can able to program. Accordingly we can able to choose whatever PLD we want. The advantage of PLDs are easily we can able to design any combinational circuit with the help of these PLDs, but the limitation is number of inputs, and whenever in number of inputs are increases, some kind of complexity we can able to get with that. So that is one kind of disadvantage we can able to observe over this thing. So to reduce the so to overcome the disadvantage, we are going for the second topic, that is the CPLD. So CPLD stands for the complex programmable logic device. So the main advantage of complex programmable logic device is here we can able to increase the number of inputs and output pins. Then we can able to go for some kind of the complex circuitries, like some kind of complex digital circuits we can able to design with the help of this CPLDs. So CPLD nothing but so group of these PLAs we can able to call. So group of PLAs we are interconnecting, or group of PALs we are interconnecting, so that we can able to call as the CPLD. So here also we are going for the programming like that only. And compared to that, so after that we went for the FPGA, and FPGA is very importantly we discussed that. So FPGA having the three blocks, that is the IO block, that input and output block, and interconnection switch matrix block, and configurable logic block means logic blocks. So these three blocks, it will be mainly there for the FPGAs. The advantage of FPGAs, here we are not burning the fuses. Some special kind of the programming here we are doing that. That special kind of the programming in tomorrow lecture I will discuss with lot of examples. And coming to these three things, so these three blocks are, so IO block and configurable logic block and interconnection switch blocks, these all are the programmable only. So these all three we can able to program flexibly and easily, we can able to make any kind of the complex circuitry, and the IO pins are very higher, so more than 150 IO pins we can able to utilize for the FPGA. So that is one of the good advantage of FPGA we have discussed. And after that we discussed about the how many what are the advantage and what is the specifications of FPGA. These all things we are discussed over here. So after that we went for the design flow. So design flow we went, FPGA design flow we went. So here, so if we want one application in FPGA, so what is the flow? So here we started introducing the hardware description language. So whenever we discuss about the hardware description language, we discuss about the VHDL 1 type and Verilog 1 type. So VHDL stands for very high speed integrated circuit hardware description language, and Verilog HDL. So this is like ADA or Pascal language similarly we made, and this Verilog we made with the similar with the help of C programming. In this two programming, we can able to write the code. So if we are writing the code, then we are doing the synthesis. So after that synthesis, we are getting direct logic logic diagram. With that logic diagram, we are checking in many ways. So timing we checking, and delay we are checking. So functionality we are checking. This all checking we are doing with the help of software platform that we discussed about the Xilinx Vivado or some other things we can able to do with that. After completion of that, we can able to do the bit file. That bit file we can able to dump into the FPGA. So these all things we discussed in the design flow. So finally we discussed about the what platform we required. So which platform we required? So simply if we are saying we need one good PC and one FPGA board and interconnection software. So PC, in PC we require the two softwares. One software is for the coding and another software for the dumping. So Xilinx Vivado, and after that some kind of the JTAG kind of the programming we want. So after that we need one FPGA. If we have these four, and we can able to make any kind of the design, and we can able to do lot of projects with that FPGAs. So that is the one of the advantage of FPGA. So that complete platform things we are discussing in finally. So these are the today contents. So what we discuss, hope these contents are very useful for you. These all are basics only today whatever we discuss. So we discuss some kind of the basic only. So some kind in detail content we will discuss from tomorrow onwards. So tomorrow we will discuss about the complete internal structure of the FPGA and how we can able to program. So we are saying that IO is program, and CL logic block is program, and the interconnection switch is program. So these three are programmable we are saying. So in tomorrow class, in this for these three, how we can able to do the programming, that all concept we will learn in the tomorrow. So after understood of the FPGAs and different types of FPGAs, we will go for the programming language. So now here we understood the process. Now we will discussing about the programming board. After that we are discussing about the programming language. Now we know the programming language, now we have the board, and directly we can able to dump in that program in the FPGA. Then we will get the whatever required combination or required application we can able to dump in the FPGA, and that corresponding application we can able to get easily. So this is about the today's session. So hope you enjoyed this session. So tomorrow with this enthusiasm, so tomorrow we will meet again. So hope so you understood this thing. So thank you all. So thank you very much. Be patiently, you listen this thing. So if you have any queries in group, my number is there, you can able to ask personally, and finally we will interact with you. So at that time you can able to ask any kind of the query. So finally you have some kind of the test. So with that test we will assess you. So with that marks we will show you, we will provide the certificate. So thank you all. Have a nice day and good night everyone.